So mangoes might seem like strange bedfellows. I should introduce the team first. We started off with Mila Bisto as our team leader. Mila and Dave and Tony put in the project and developed it in the beginning. Dallas and I were recruited later in the process, and Raj is our PhD student who's just recently submitted his thesis. And Alan is our technical officer who helped us with all sorts of exotic ideas that I came up with along the way. Why are we looking at mangoes? It's because it's the largest horticultural output in the Northern Territory. Over the course of this project, the outputs have increased considerably, and we produce around about 50% of the whole Australian mango crop. Of that 50%, or of the Australian mango crop, you might wonder why we're working in Kensington Pride. So even though it's an older variety, it still makes up just over half of the Australian mango output. Calypso is catching up. You're probably familiar with R2E2 and some other varieties. And we've got some National Mango Breeding Program varieties coming out in the next few years. So you'll see they haven't numbers as names at the moment, but keep an eye out for them because they have beautiful blush, lovely flavours. They've tried to keep those volatiles that KP have in them, and they have fantastic bench life. So I can recommend the new varieties whenever you get access to them. So some of the data in here, I've tried to keep our data so that it's got relevance for the future. So when I've had the opportunity on a smaller scale to do some work on these, they're not in orchards at the moment. So when you see things like 1201, 1243 and 4609, they're the new varieties that will be coming on stream in the next decade. Also in the Northern Territory, traditionally mangoes have been grown in Queensland and it's transitioned to the Territory in the last 50 years or so. Really different climate and soil characteristics compared with Queensland, and the management practices haven't been transferable. And we have a quirky lot of growers sometimes historically in the Territory, and we have extreme differences in management practices. So this project is really to put everything on, try and develop an evidence-based footing for nitrogen management in mangoes. So we asked the questions, which are very similar to Marguerite's, or we thought we'd better start off with the basics, start a nitrogen budget for mangoes grown in the Northern Territory, work out how much nitrogen is too much, and I'll explain the implications of too much nitrogen for mangoes, and also have a look at what's happening in the soils. We have really impoverished ancient soils that struggle to hold on to any nutrients at all, particularly with the tropical rainfall we get annually. So the first experiment, or the first material that we worked on, actually had a little bit of lead time while the project was being proposed. And basically what we wanted to do is actually measure the soil applied fertiliser uptake. So we had to establish our own orchard because we wanted to do a lot of destructive sampling, and commercial orchards aren't very keen on you destroying their highly productive, highly valuable trees. So this had a bit of lead time, and with hope for getting funding, so we were able to actually grow, graft and plant, and so we had a little orchard established, ready to go. The trees in those orchards were fertilised with labelled fertiliser with 15N labelling. And from that work, we can tell you that the younger trees had a 25% nitrogen nitrogen uptake efficiency, and the maturing trees, as they came into commercial production, actually took up 50% of the soil applied nitrogen, which is quite good, really. So the figure on the bottom right shows you the total 50% uptake, or just over 50%. But you can see these actual quantities, if you're not familiar, when we're talking about 5.7, 11.4, I've put everything into kilograms per hectare just so that's standardised, so we can look at all the information relatively. But just on a per tree basis, so you can get your head around that, it's 20, 20, 40 and 60 grams of nitrogen per tree, which is not a lot, which is why the slope on the drop of nitrogen uptake efficiency is quite small. The other management practice involving nitrogen that growers routinely use is the application of potassium nitrate during flower and fruit set. They put that on really for the potassium because they think that improves the maintenance of maintenance of flowering and also fruit set and maintaining the number of fruit on the panicles, because you get millions of flowers but you only end up usually with 1 or 2 fruit per panicle, which is fairly inefficient. So they try and maximise that, and we've also had some anecdotal information that growers were starting to apply nitrogen, but with foliar application. So we'd actually thought we'd quantify what the uptake was, and we found that it was between 25 and 40% of nitrogen uptake efficiency. This is across the leaf cuticle over 2 days, which is actually comparable to most soil-based fertiliser uptake efficiencies. So if you can only put it on in dilute forms, but it does actually take up quite efficiently, and the actual proportion of nitrogen in the leaf that was taken up from that solution was between 4 and 6%. And we did find some varietal variability amongst the KP Calypso, which is B74, and the new varieties. And how much nitrogen is recycled in the orchard? You know, we all look at the litter drop and the prunings and things in an orchard and don't pay very much attention, but we wanted to quantify how many nutrients or what was recycling on the orchard floor. So we collected the litter over a year and the prunings and processed them all. And you can see, if you have a look at the top left there, that's a traditionally managed Kensington Pride orchard. Top right is an orchard that is managed similarly, Calypso, but very selective picking. And you can see that peak of orange in the middle there, which is post-harvest. That's the fruit drop. That's all the fruit that was left on the trees. So that's a wasted resource. This is another thing we discovered too, was how much output, how much of the yield is actually being wasted and could be, it's money that could be earning income. Bottom left is an orchard that received almost no pruning that particular year, and you can see the high leaf litter content all during the year. And then the bottom right was an orchard that was having all the trees reworked and having just basically a big renovation. So they had almost no leaves, and the litter was almost all in the prunings. So if you look at that in terms of volume, it's actually quite similar across all 3 out of the 4 orchards. It's actually 4 tonnes per hectare of litter that's hitting the ground and then decomposing, recycling. Again, this reflects beautifully a really big range in management practices. And then you get to how much nitrogen is recycled. This was surprising, a bit of an eye-opener. 17 to 27 tonnes per hectare of nitrogen is being recycled on the orchard floor. Now that's about what is most farmers, or that's in the ballpark of what orchardists actually put into the orchard into soil-based. So there's an equal quantity. So you've got half your fertiliser just recycling on the floor of the orchard every year. And I couldn't resist the having all that material picked up with sweat and a lot of work to find out what other nutrients were cycling. So I did a subsample, and in that litter, 40 kilograms a hectare of calcium is being recycled, 1.5 tonnes of carbon. Not surprising, a lot of that gets dropped. It's easy to reproduce. Potassium, 18 tonnes a hectare. I mean, these are big volumes. Micronutrients as well, still significant amounts. So I know it's a bit beyond nitrogen, but still, I mean, this is money in the bank. So it's nice to know what you've got already in your orchard as an asset. And I learnt about a new field that I'd never heard of before, leaf nutrient economics. This is another small thing, value add, that I couldn't resist as well. You measure the nutrients in a mature, fully expanded leaf, and you compare that with a senesced leaf, which is still attached to the tree, so about to fall, but still attached. And discovered that over 50% of the nitrogen is actually resorbed back in the tree for reuse. This is very well investigated in deciduous trees, but very little in evergreen. But one thing to remember is that it tends to be respond to the environment that the trees are growing in. So the more available any nutrient is, the less of it's resorbed. So 50% resorption is fairly middle of the road. And if you just think about our phosphorus deficient soils, nearly all the trees, in the literature and in the mangroves, almost all the phosphorus is resorbed back into the trees because it's it's a hard one, a nutrient that's hard to replace. I thought we'd have a look at the nitrogen movement actually within the tree, because we don't really have evidence-based any evidence to support when we actually apply fertiliser. So we developed a method where we could lift whole trees and we put that into practice for the fertiliser uptake experiments I mentioned before. And the idea was that I'd infuse the trees with labelled nitrogen and then lift them at the principal phenological time points in a season, which is during the active growth, during the resting or quiescent period, during flowering and fruit set, and then post-harvest, after harvesting the fruit. And we also collected the litter during this time too. So basically I wanted to account for all the nitrogen in the system over a season. And it was quite interesting. If you're wondering how I did get the nitrogen into the tree, it was by using transpiration in the tree, the passive flow, where you have the leaves transpiring and you have negative pressure in the xylem. Basically, I gave it a transfusion of labelled nitrogen into the trunk, and which worked very well. If you ever want to do that, just make sure you do it in the summer or dry season when you've got really negative pressures. Don't try. It's very hard to do in the humidity, over the wet season or when you've got really high humidity for obvious reasons. But it still works pretty well. It's the difference between uptake over 24 hours versus about half an hour to an hour. So it's quite efficient. So the nitrogen was introduced into a system where there's passive flow, and I could calculated the distribution across the tree, and the points of interest really are the very well documented leaf nitrogen, which is more than half of the whole tree nitrogen, and the roots, which is second from the bottom, which is the grey line. They actually start off at about 17%, and then they increase just under 20% at flowering and fruit set. So that suggests to me that the roots are becoming more active as the fruits are acting as a sink, taking nitrogen from the leaves via near the fruit and via the branches. I can tell you now that a mature tree, as it comes into commercial bearing, contains nearly 600 grams of nitrogen, and that decreases over the year, which was something that was unexpected. And so you can see with the green at the bottom, we're starting off with the green circles. You start off with 600 grams, and by the end of the season it's down to about 350, just over 300 grams. That's a lot of nitrogen to be losing. So where does it go? And just in case you're thinking the trees are a different size, I've actually on the red triangles are showing the tree nitrogen relative to the tree dry weight. So you can see that they sort of run in parallel. So where did the nitrogen go? To the leaves initially, as it would have gone up there with a big bang. Relative to the amount of nitrogen in the whole tree, I put in 0.38%. So nothing that should upset the tree or cause leaf death. We actually know how much it takes to cause that, because I generated some leaf litter for our PhD student. And so this is the tree nitrogen, the percentage derived from the infusion. I was really surprised by this. So after the first point, we can see that through the rest of the season, every part of the tree is dropped down to the amount that I put in the tree to start with. So what this tells you, just to drill down into that one little bit more, you can I separated the xylem and the phloem, and you can see that the phloem has more nitrogen in it, as you'd expect, compared to the xylem. But the interesting thing was, if you look at the bottom figure, is that the nitrogen derived from the infusion is down around 0.2%. So that means that little bit of 2 grams of nitrogen that I put into the tree in December had completely spread around by active transport in 70 days, which was a lot faster than I was expecting. So everything is really dynamic and fast in trees. So I don't know if that's published anywhere, but I'll look into that in the next few months. But I didn't expect it to be so dynamic. I thought we might get some source and sink action happening and be able to, draw all sorts of conclusions. But basically, it was just super fast and a done deal. The other confirmation of that, in the top right figure there, is I centrifuged out some xylem sap after stripping the phloem off the branch tips. And from that xylem sap, you can see the triangle line, which is actually the actual nitrogen content in the xylem sap. And then you've got, again, the absolute flat line of the 90% nitrogen derived from infusion. So that just reflects that massive, really, really rapid transport. How much was recovered in the trees? We started off with a super high recovery that faded down to 66% by the end of the season. Now, there is some published work that also found this from South Africa in the 1990s, but they put it down to the loss of nitrogen in the fruit and the litter. Now, that's not the case here. We collected all that, we've accounted for all that, and there's still this massive loss of nitrogen in the system. The nitrogen derived from infusion from the litter, and the top figure, you can see that the panicles from last season are dragging their feet. They are senescing panicles from the season before, so they clearly aren't going to take up very much labelled nitrogen. And then during flowering and fruit set, and there's a generation of the fresh panicles for fruit that season, it pops up again as you'd expect. My hypothesis for where all that nitrogen's gone, it's just a working hypothesis and I don't know for sure, but that amount of nitrogen to go when you've accounted for all the fruit and litter. Now the litter, when you extrapolate this out, it actually worked out to be about 15 kilos per hectare, which is consistent with the fully functioning commercial orchards. So it's not lost in the litter, it's out of the system. And I'm wondering if maybe, there's quite a lot in the literature in the last couple of years about root exudates and nitrogen being the trees exuding nitrogen-based exudates or all sorts of material and water. It's so that to help the drought tolerance of the trees, and this also coincides with the dry season where we don't get any rain for 6 months. So this is one possibility. How much nitrogen's too much? We know you can have a look at the biannual yield variation in KP here. Goes from 20 tonnes per hectare in 1 year to 40 tonnes the next, and this is what we're working at. And you can look at the yield return ratio on the bottom there. You've got a yield return ratio for the zero because they all got the minimal potassium nitrate sprays. So you're getting very little, you're getting no benefit for more nitrogen inputs. It's just costing you money. How much nitrogen's too much? Now you can probably see there, it's a fairly easy visual. We're looking at fruit ripening between 3 and 10 days post-harvest. And when you get to 25 kilos of nitrogen per hectare and 50 kilos of nitrogen per hectare down the bottom, you can see you've got stay green skin. This is a post-harvest defect that doesn't resolve with ethylene treatment, so you've got fruit that's going to market that looks very unappealing and unripe, and there's supermarkets and agents don't like it. So basically you've downgraded your fruit and it's lost half its value with this stay green skin defect. And that's quantifiable using colorimeter. So basically when you're at those higher nitrogen levels you have skin on fruit that is less red, less yellow and darker. We tried to reproduce this the second year to actually do some ethylene treatments. We found some other interesting things as a result of the ethylene treatments, but we couldn't reproduce the stay green skin. The fruit takes out about between 10 and 20% of the tree nitrogen, total nitrogen, and it took out, when we had a 40 kilo per hectare yield, it took out double the 20 kilo per hectare yield, basically. There was no adjustment. Okay, so here's my diagram that you've all been seeing over time. I think I've filled in all the gaps now. It's a bit rubbery and it varies a lot between seasons, but we've been able to account for the inputs with the soil applied fertiliser, minimal inputs out for the volatilisation, which Dave will talk about in a minute. We've got the sprays, the fruit, the prunings, the litter, and then we've got the mushy figure, which Dave will talk to, which is mineralisation and the decomposition products. So basically, it's a monitor and vary situation, and clearly your starting point's going to be applying what your yield took out with it, which is about 1% of the fresh weight. And watch out for soil nutrient mining, because it's very easy to do.
So I think from the soil side of things, these Northern Australian soils are pretty underrepresented in a lot of areas of research. So very different to the heavy black vertisols that we're working on down in New South Wales on the dairy project. These are mainly candasols, quite well drained, low CECs around sort of below 10. So just getting some basic numbers on what's happening in these soils is quite critical. One of the interesting things that come out, and I think one of the useful things for the industry, particularly in this sort of political environment at the moment around low carbon agriculture, is just some basic numbers on nitrous oxide emission factors from those fertilisers. So as Joe mentioned, these are relatively low input systems, but according to the inventory, the Australian inventory, they're still basically listed as under the same umbrella as intensive horticulture in Victoria. So getting some more accurate numbers on that is quite critical. And so this was the research that our PhD Raj did up in Katherine and just out of Darwin at the KRS site, which you all visited, using our automatic chamber systems. We basically looked at the influence of litter and urea. Ultimately, there was no real influence of the litter in combination with the fertiliser. The fertiliser just didn't hang around, which is not a surprise in these highly heavy rainfall, high temperatures and high leaching soils. And so we didn't see much of an interaction, but what we did see is quite low emissions. Once again, not too surprising, but as you can see by the right-hand column there, our emission factors were actually quite well below even the Tier 2 default for horticulture, so that's 0.85, the IPCC is 1, and our highest treatment, and we were putting it on the upper level of the industry, was only 0.17. So our losses were really small, and I think that's a bit of a climate smart agriculture take home for the industry, which is good. One of the core objectives of this program was also looking at enhanced efficiency fertilisers. In the case of the mangoes, because our inputs are so low and our conditions are so extreme, we sort of took the approach of actually looking more at soil ameliorants rather than actual the nitrification inhibitors, etc., which we've done in other projects. So we basically looked at a couple of different options that they have up there. These are either locally produced or ones that are standard, I suppose, just for comparison. Apologies for the accesses on this, they've seemed to have gone a bit haywire. But we looked at, this is just in a lab incubation because obviously doing leaching under mango trees in the field is not particularly easy. So we just looked at the potential in these soils from different products. Interestingly, one of the biochar was a mango-derived biochar, which was produced by one of the producers up there. And even though it was where all the prunings that Joe talked about, he thing in the ground and burnt it. Very technical. So, it was a biochar. It probably wasn't, as stable as some of the other ones, but it actually still produced quite a lot of nitrogen mineralised over time, which actually meant that we had quite high nitrate leaching, which was interesting. But basically the zeolites, unsurprisingly, just because of their high CEC, our CECs are below 10, so even a small increase in CEC can make a difference, and that's basically what we saw here. And that's the far right-hand side, and apologies that you can't actually see that graph. I'll hand back over to Joe.
Okay, so the industry knowledge that we've created, we've actually put some evidence together now. We've quantified the soil nitrogen uptake in the Northern Territory. We've actually now got some numbers for nutrient cycling on orchard floors. We know how much gaseous emissions we have. We know how much how fast the decomposition is, which basically is 100% a year in Darwin and 85% a year in Katherine. So you can accumulate a few things, but in the top end proper, no. We've constructed the nitrogen budget, we've characterised nitrogen and carbon activity in the soils, we've determined where the cut-off is, where you have to start to worry about reducing your fruit quality, no yield advantage, And for those in the Territory that are looking at this in the future, the work done in the Katherine is lightning, and associated nitrogen deposition is 1 kilo a year per hectare, half from bushfire particulates. And our project outputs, we've had a lot of interaction with industry, and I imagine there'll be a lot more in the future. We've had Raj submit his PhD thesis recently, which is fantastic, and we've got journal papers already published, and with more coming in the future. Thank you very much.